Good evening. I'm Dr. T. S. Saranan, Associate Professor, Department of Computation Intelligence, SR Institute of Science and Technology, Katangulattu. And we are going to see about graphs and types with these applications. Now, before seeing about the graphs and its application, first we should know about the concept of what is graph. Graph is a non-linear data structure consisting of vertices representing objects, edges representing relationship between the objects. Now, it is mathematically represented as vertex and edges. We know that the graphs are represented in terms of a circle which indicates vertices and a line which indicates the edges. Examples are cities connected by roads or friends in a social network or computers in a network. One thing we want to say here is the vertices are called as V1, V2, we say as V1, V2. Actually, in a real situation, these vertices are called as the computers, and edges, the lines what we specify here, are called as wires. That's a physical situation. In a lab, you'll be seeing about the computers connected by wires. The same thing can be said as vertices as computers or nodes, and edges as the wires connecting the computers. This is a physical view of a link. In a friends in a social network, we cannot see such a link. It is invisible. Cities connected by roads. That also we cannot connect those things. Simply speaking, when you're going to see about your Google Maps, you can see multiple boxes available, and those boxes are connected. Multiple boxes are called as cities, and the roads are called as the edges. And GPS location or Google Maps location or location-based services widely used. Only based upon these vertices and edges, the shortest path is going to be calculated. And now we can see about the next thing about the graph, how a GPS location is going to be calculated. How the GPS location is calculated is nothing, but you are going to find the weight of the node, and based upon the weight, the shortest path is going to be found. Now clear the statement that you can see in a Google map location, everything is a graph, and the graph is given in the form of colors: red, yellow, green. We say the red means it is most highest traffic. And every color has its own meaning. So, as per the concept of a graph, we say that highest weight should be discarded and minimal weight should be considered. As per the concept of Google Maps, the weight is assigned to the red has highest intensity. Based upon the intensity of the color, the weight will be increased. Highest intensity colors will have highest weights. Lowest intensity colors will have lowest weights. Automatically what happens is the highest weight node will not be considered as the shortest path. and lowest weight node will be considered the lowest weight, and that will be considered the shortest path, and navigation will be done based upon the shortest path. So the intensity of the color defines the weight of the node as per Google Map is going to be considered. This is the way shortest path is calculated in Google Maps, and location-based services are enabled. Now, next we can see about the components of graph. Components of the graph we can see about vertex, edges, degree of a vertex, path, cycle, connected component. Now, we can see one by one. Definition is known to everyone. Main impact of having this video is not to give a definition for every term, to provide a solution with the help of example and with real-time situations or real-time applications. Because more interviewers ask such questions to students or job seekers. No one is able to provide correct answers with applications. They are ready to answer with the definition. No one is clear about the application. No one is clear about the further process. So for that only, we are going to have an example with how these are related. Vertex. We have said that A, B, C, D, E are vertex. Edge. A to B sides, B to E sides, E to D sides, C to D, and A to C. These are edges. Next is degree. Degree is the number of edges incident on that vertex. What's the mean by a term? Now, number of edges connected with the vertex. That is the meaning of the term. Number of edges incident on the vertex. Number of edges connecting the vertex. A is connected to B, connected to C. So A has a degree of 2. Now we can trace. A has a degree of 2. And B is connected to A, E, and D. So B has a 3. And C has connected to A and D. So C has a degree of 2. D is connected to C, B, and E. So D has a degree of 3. E is connected to B and D. E has a degree of 2. F is connected, F and G. Those nodes are not connected. These are nodes available. So these are the degrees of the vertex. So how the degrees are calculated? Degrees are calculated based upon nodes which are connected to each other. Next is path. How the path is going to be calculated? Where now we can say every consecutive edges connected by a vertices. A to B, B to E, E to D. This is the path. And A to B, B to E, E to D. We say this is a path. Then what may be the path cost? As no weight is provided, we can say the path cost is 1 for each edges. So 1, 2, 3. Yes, A to B is 1, B to E is 1, E to D is 1. So totally 3. So there are many path costs can be taken. A to B, B to E, E to D, D to C. Each connectivity provides one cost. So 1, 1, 1, 1. Totally A to B, B to E, E to D and D to C, we have path cost is 4. This is for an unweighted graph. Unweighted undirected graph. This is an unweighted undirected graph. What's the meaning of the term unweighted undirected graph? Here we have no weight, no arrows. When no weight and no arrows are available, that is called as unweighted undirected graph. We can see about the same example, the same description for the weighted graph example also. Now, next one is cycle. Starts and end at the same vertex is called a cycle. Here we can say that A, B, D, C, A. One of the example. So a cycle is formed A, B, D, C, A. Starting and ending should be same. That is called as a cycle. And when you are going to say about A, B, D, C, A, what is the length of the cycle? 1. Here also weight will be 1. Here 1. Here 1. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. So 4 will be the length of the cycle. Next one is connected component. What is meant by the connected component? Connected component is a maximal set of vertices in which every pair of vertices is connected via paths. Then how the connections are provided? A, B, and D, E. Now, another question arises here is A, B, D, E is given, but this is not correct because we had to write it as A, B, C, D, E because A, B, D, E we are giving as a connected component. As per the logic, A is connected to C also. As per our statement, A, B, D, E is not said as a connected component. Or it can be weakly connected because A, B, D, E is not going to be a fully connected because C is also connected to A. Next, I think we'll be clear with these concepts of a components of a graph. And now we can move to the next with the directed graph. The same components of the graph we are going to explain with the help of a directed graph. So here also vertex will be same. What is the vertex? A, B, D, E, F, G. The vertex will be same, no change. Edges is on the edges. Here there are two types of edges. One is forward edge and another is backward edge. Those are incoming is called as forward edge. And another one is called as the backward edge. This is forward means this is backward. A to B is forward, B to A is backward. And another statement can be said as A to B can be said as incoming, B to D can be said as outgoing. Now you can see about the degree of the vertex. Degree of the vertex is fully based upon incoming and outgoing. So here, number of edges coming into the vertex will be called as in degree. Number of edges going out of the node is called as out degree. So you will have in degree and out degree. Now you can see about the detailed description with this diagram. A is available, A to B. Now, in degree, it is nothing but the in degree for B, A to B. B is having one in degree. And B to D, So B has one out degree, which means that A is giving an input to B. So in degree is 1, B is giving an out degree. The one node is, one arrow mark is going outside. Simply say what the arrow mark. Arrow mark is going outside, that is called as out degree. But A is considering there is no input coming for A. Only A gives output of to 3 nodes, B, E and C. So we say that as A out degree will be 3. C. C is connected to F. C is connected to F. And so C has one out degree. One node is out degree. Nodes going outside. C is getting one input from A. So C has in degree and out degree as 1. D. One node is going outside, one node is getting inside. So that is 1. E. There are 2 inputs are received, one from D, another one from A. So we have E sent 2 input nodes are 2 in degree, and E has one output, that is called one out degree. F has 1 in degree from C and another in degree from E. 2 inputs are received from C and E. And there's no outgoing node. So we can say that is 0. Here no G node is available. So we have placed as 0. If no node is available, we can place the in degree and out degree as 0. Now, next you have to see about the path. Here, in the previous example, we have seen about the path. We have seen the path as that is undirected. We said that is path can be of anything. Here, as we are going to have arrows, path can be based upon the direction of the arrows. A to B, B to D, D to E, E to F. That is called one path, A to B, B to D, D to E, and E to F. You cannot continue from this because there is no forward edges. This is called as forward. But arrow is not forward edge is not available. So we stop at that point. One, this is the way of giving a path. Now, the length can be calculated as there is no weight. You can put as 1, 1, 1, 1. Forward edges based upon direction I calculated 1, 2, 3, 4. So the path can be given as length of 4 edges. A, C, F. So path can be given for 2. 1 plus 1 is 2. Here this path is 4. Next, cycle. As we know that when we are going for a cycle, the starting node should be the ending node. Here as a direct graph, forward edges are not available to connect the destination. A is a starting point, A to B, B to D, D to E, E to F. Then forward edges are not available to reach A. So we finalize that there's no cycle. We clearly says that this is a directed acyclic graph because no directed path is returning to starting vertex. This is the component of a graph. Next, connected components. Here also, we can say the connected components by removing the directions alone. A, B, E, F. Here, A, B, D, E, F can be given. But this is called as weakly connected. Why? Because A is connected to C. we cannot say that as a connected component can be A, B, D, E, and F cannot be said as a connected component. Because the connected components are C can also be included because C is also connected to A. So the output can be written as A, C, D, E, F. A, S, A, B. Next. Now, here A, B, D, E, F. This is the way in which connection can be given, but C is also connected to A. We cannot say that C is not connected to A. So we add C and we say this is the connected components of this graph. Next type of graph. We all know about the type of the graph. There's no issue in the knowing about the type of the graph. But the thing is, we don't know about the applications of those things. And that we know there's no direction. But where we are going to use, when we are going to see about the applications of an undirected graph, we say that Facebook friendship, railway connections, road maps. These are the various information about undirected graph. These are the various applications. Next, directed graph. The first example what we saw previously, that is undirected graph. Second one we saw is a directed graph. Directed graph has directions. Now, where we are going to use the direction, one-way roads, Twitter followers, and task scheduling. These informations will be called as directed graph applications. One-way road, because forward this alone will be available. Task scheduling, because HODs may assign the task. That's one way. Staff is not going to assign any task to the HOD. So only HOD is going to assign the task to staff. That is one way. That is task scheduling. That is called directed graph. Example for a directed graph. Weighted graph. Each edge has an associated weight or a cost. For that only we saw about GPS navigation. I informed previous the starting itself how the GPS is going to be calculated, how the minimum distance is going to be calculated. Everything is based upon the weights. Network routing. The same. The flight is finding the correct path only based upon the shortest path. Because flight has sensors, it analyzes what will be shortest path and it reaches the destination. So those are called as example of weighted graph. GPS navigation has explained clearly at the starting of this graph. No need to put the same. Unweighted graph, no weight is available. When weighted graph is there, weight will be considered and it is added to find the shortest distance. Similarly, in GPS navigation, the intensity of the color will be taken as the weight of the graph. Highest intensity will be taken, highest weight. Unweighted graph means no weight is given. And as no weight is given, we are specifying the weight as 1 for each nodes. Each edges will carry one weight and node calculation will be done based upon 1. The example can be the applications are social networks, friend recommendations, everything is unweighted graph. And Next is connected and disconnected. What is connected and what is disconnected? When you're going to say what the term connected means, whatever you are going to see in internet is going to be there. When connections are given, when the internet is accessible, it will be called as a connected graph. When shortest path able to found, but the internet is disconnected, which means that you cannot connect with the server, you cannot reach the system. That will be called as disconnected graph. Internet connectivity can be taken as an example. If it is working good, we say that is a connected graph. If internet is not connected, somewhere there may be a disconnection. So only internet is not connected. That will be called as a disconnected graph. Next one is cyclic graph and acyclic graph. Cyclic graph. So the cyclic graph is nothing but a road with a ring road. We are in Chennai. Now, ring road in the sense Chennai, Tambaram, Velachery, Gindi, and Chennai. Yeah, buses will be there. And Kilambakam bus stand has been opened. Starting point will be Kilambakam, ending point also will be Kilambakam. The starting and ending point will be same. Such a graph is called as such a mechanism. Roads will be the road network with ring roads. That will be example for cyclic graphs. Social networks, friend or friend was friend, a cycle will be there. Friends a friend, connection will be there. A cycle will be there. Circular metro railway, a starting and ending point will be same. Now, autonomous train is going to be planned to operate. So, your autonomous is a process in its the graphical structures are going to be taken based upon shortest path. It reaches the destination. Traffic is there that controls the speed. There are many things behind that. Traffic is there, reduces the speed. Based upon graphical structures alone. Because we represent the route in the location-based services, the route is defined as intensity of the color. The intensity of the color is high, traffic is more. Circular bus. The starting point and ending point is same. Now, many circular buses are enabled with GPS locations. It informs what is the current point, that those who want to get on can get on. What is the next stop? Everything is involved only based upon the GPS location. The graphical structures are location-based services involved in this. Next, acyclic graph. Acyclic graph is nothing but family trees. Grandfather will give instruction to father and they do grandchild and they will do. No backward. Son will not give the order to grandfather. A child will not give the order to grandfather. Orders will be from top to bottom. Organization hierarchy, vice chancellor, dean, and chairpersons, associate chairperson, HODs, staff. This is a hierarchical process. They will give orders in the hierarchical order. This will be called as example of acyclic graph. Only top to bottom approach will be there. No bottom to up approach is available. Now, next one is you are going to see about a complete graph. What is meant by a complete graph? Complete graph is nothing but you can say about the term concept of network topologies. Network topologies are called as complete graph because you can see about the mesh topology. Everything is connected to one node is connected to another. How the mesh topology will be available? A node is available. is a network topology, mesh topology only. Here, one. Here, each is say the computers are connected to each other. This is the way in which you are going to say. You can say this is vertex V1, this is vertex V2, this is vertex V3, vertex V4. These are a complete graph such that every vertex is connected to another. And each vertex is connected with the help of edges. These can be represented in terms of a complete graph. So topological structure, network topology, the mesh topology, what we are studying in computer networks, everything comes under complete graph. Next one is here. We are going to see about the concept of bipartite graph. What's the bipartite graph? Bipartite graph is the graph in which set of vertices can be divided into two disjoint sets such that every edge connected a vertex from one set to vertex in another side. So vertex from one side connected to another side. An example can be given as doctor-patient networks. Doctor will be available, patient will be available. A hospital can have many doctors, a hospital can have many patients. The doctor will be connected to a patient based upon the disease available for the patient. Yeah, ortho doctor connected to the ortho diseased patient. So a person of one set will be connected with person of another set. Linking is provided based upon the relationship. Here, diabetes doctor will connect with diabetic patient. Cardiologist doctor will connect with heart patient. So relationship is provided from one set to another based upon the relationship. Then customer products. The same relationship. Customer will be purchasing products. N number of customers will be there, and product n number of products will be there. Customer will buy products based upon their wish. This is called bipartite graph. I think this idea will be clear for you to understand the type of the graph for the real-time applications. Because everyone know about what is the graph, we say about only definitions alone. But this video is intended to provide a clear description about what are the various applications in each type of graph. We can see about the various algorithms related to these graphs in the next videos. Thank you.